After choosing a conceptual design option, you'll often want to convert your conceptual mass into real building elements so you can continue the design development and add details to the building. To convert the conceptual mass, switch to the Massing and Site tab, where you'll find several tools which will allow you to change faces of the conceptual mass into building elements. Let's start with the floors. We'll choose the Floor tool, then drag to select all of the mass floors. We can choose a type for the new floors. We'll choose the 3-inch lightweight concrete on a metal deck. And when we're done, say Create the Floor. Revit converts the mass floors into real building element floors. Let's choose that lowest floor and change it to a type that's more appropriate for a ground floor. We can choose the floor and change its type from the lightweight concrete on a metal deck to a generic 12-inch floor, which we'll use to ultimately model a floor slab and a foundation system. We can now turn our attention to the roofs. Let's choose the Roof tool. We'll choose the different roof surfaces. I'll use the Control click to get this one, as well as this one. We'll choose the type of roof that we want to use, in this case the insulation on metal deck, and say Create the Roof, and those surfaces will be converted too. We're now ready to convert the walls, so let's again return to Massing and Site, choose the Wall tool, and choose the surfaces that we want to change. I'm going to choose the EIFS on metal stud wall system and use it on these side walls, this side, and using the view cube to change our orientation, select that side. And finally, we can change the remaining surfaces into curtain systems. Let's choose the curving surface, this front face, this face on the extension. Let me change those first. We see that the curtain system doesn't have the shape that we want. Rather than having the horizontally oriented panels, I'd like that to actually be vertically oriented panels. So I'm going to create a new type and change that. Let's duplicate this. We'll instead make a 10-foot by 5-foot system. Change the dimensions for how the grid is laid out. Say OK. We can now reselect those elements using the Modify tool and change their type to the new one we've just defined. Let's wait just a moment as the curtain system elements regenerate to follow our new pattern, and you'll see that the pattern is applied to all those surfaces that we'd selected. Let's use the View cube now to switch our orientation, and from this orientation we can again go to the Massing and Site tool, use the Curtain System tool, and choose the remaining surfaces to have the curtain system applied to them. Again, say Create the System. Let the system panels be applied to it. Let me reorient the view back to the original. And now we can turn off the visibility of the mass if we like, and see only the building elements that we've created using the mass model as a template. Revit offers several kinds of schedules that you can use to tabulate key quantities of the building elements and compute costs. One of the most useful types is a schedule quantity report that will list out the properties of the building elements and let you tabulate them. Another very useful schedule is a material takeoff, which will aggregate the quantities of various building materials across the building elements and let you associate costs with those materials. Let's start by creating a schedule of the wall elements in our project. The surface area of the walls is often one of the key quantities that we can use to estimate one of the major cost components in our project. We'll choose the wall elements, then choose the fields that we'd like to have show up in our schedule. We'll choose the family and type. Let's choose the area of the wall elements, as well as the cost. We'll say OK. Let's take a look at the schedule. Let's enhance this schedule to make it look more like a preliminary estimate. We'll stretch out the first column so we can see what the wall type is and change the title to be Preliminary Estimate of the Walls. Next, we'll add a formula to compute a preliminary cost for the walls by multiplying area by the unit cost. To do that, let's go to the fields. We'll add a calculated value, and we'll add a field called item cost. The formula for this new field will be area times the cost. And again, I'll divide through by 1 square foot to normalize the units. Let's go ahead and sort this by the wall types and add a grand total. We can format these fields to make them right aligned, and also add a total so we can tabulate the total cost. We're now ready to start entering cost data. If we know that the cost of the EIFS system is approximately $60 a square foot, we can enter that value, and when we click out of the field, it's going to warn us that it will change this type parameter for all instances that use this wall type. We'll say OK to that. And it computes an item cost for each of those wall elements. Let's format that field to make it a little more readable. We'll format the costs. We're going to give it a currency format, show the $sign, and put the commas in to do the grouping. We can use a very similar procedure to create a schedule, which will tabulate all the curtain panel elements. Again, choosing a schedule or quantity report. We'll choose the curtain panels. Let's go ahead and put in the family and type, the area, and the type cost. We'll add a calculated value called item cost, which is defined as area times cost divided by 1 square foot. Say OK. And then we can sort the schedule and format the columns to create a similar preliminary estimate for the curtain wall panels. The schedule that we've created lists each of the individual curtain panel elements. We can type in a cost per square foot for those curtain panel elements. We'll again get the warning because we're changing that cost for all the elements of the same type, and we're computing the item cost then for each of the curtain panel elements. In this case, because there are so many elements of the same size, it may not be useful to see each of the panel elements listed separately. So what we can do is go to Sorting and Grouping, turn off the Itemize Every Instance, and we'll still have our report, but it'll summarize all the different panels of the same type together so we can see the total area of all those panels as well as the total cost for all those panels. Let's look at another very useful kind of schedule that'll tabulate the quantities of materials across all the different categories in our project to help us build an estimate. It's called a materials takeoff, and if we choose to schedule elements from multiple categories, we'll get a combined schedule that includes floors, walls, roofs, and all the different categories of elements. In this schedule, let's include the family and type, the material name, the material area, and the material cost. We'll also add a calculated value called material item cost, and this will be similar to the other ones where we summarize material area, multiply it by material cost, and divide through by 1 square foot to normalize the units. Let's say OK. Let's sort and group this schedule primarily by the material name and secondarily by the family name and type. We'll put a header and a footer on each of those different groups so we can compute subtotals. Let's even include a blank line. Then we can format the materials cost as a right aligned field. Let's check to make sure that's showing for currency, and it is. And also the materials items cost, again as a right aligned field. Check that. Let's change that so our new computed value also displays as currency with digit grouping and the $sign. Say OK, And finally, we'll add subtotals for the material item cost as well as the material area. Let's say OK and look at our schedule. Currently, the schedule is showing all the different building elements sorted by the materials they contain, but it's not showing any cost data, and that's because we haven't yet entered material cost. If we enter some material costs, for example, for the square foot of the cast-in-place lightweight concrete of, say, $50, notice that this unit cost is applied to all the different elements that use this material. Similarly, if we scroll down and take a look at the metal deck, you'll see that we're using the metal deck material in two different applications, both on the roof as well as on the individual floors. If we fill in a value for that material, you'll see that again it populates all the rows with an estimate of the cost for using that material in all those applications. So using a materials takeoff is a very effective estimating strategy for when the cost is primarily driven by the cost of the materials across all the different building elements. Another type of schedule that's very useful for estimating within the Revit environment is a materials takeoff of parts. And let me switch to a simpler model where it'll be easy to see the value of using this approach. Here we're looking at a model of a very small portion of a building composed of 3 different wall elements and 1 curtain wall segment. And if we take a look at a wall material takeoff, similar to the one that we created in the last step, you'll see that the materials are grouped. We're showing the area of each of the different wall segments. We've associated a cost with each of those materials types, and we've computed a material item cost. Now, this is a fairly accurate schedule, but you will notice there is one inaccuracy that we want to take care of, and that is that the materials actually use the same material area all the way through the structure, and that's not quite accurate. The outer layers will be using more material, the inner layers will have slightly less material. Now, this may not seem like a very big difference, but across a large project, this can add up to quite a difference. So to correct that and have a more accurate schedule, what we can do is actually use parts. And to do that, what we'll do is choose some wall elements. For example, this one, and this one. And we'll create parts. Again, parts will divide those elements into the different layers so that we can get a more accurate takeoff of the quantities of each of the different layers. You can see now that the wall has been separated into the brick layer, the stud layer, the interior layer. So let's take a look at what that looks like when we schedule the parts. To create a materials takeoff of the parts, we use the same procedure. Choosing material takeoff, but rather than multi-category, we'll now choose parts as the category. And within the list of available fields, we'll choose very similar ones. We have a few new additions, for example, the original family and the original type. But the materials-based fields remain the same. We'll choose material name, material area, and material cost. And we'll also need to add the calculated value to compute the item material cost, just as we did in the last step. The schedule created by the part material takeoff is very similar to the one created by the wall material takeoff, but with one critical difference. You'll see that as we look at the different values for the materials on the inner and outer layers, you'll see differences in the quantities. For example, at the outer layer, we're showing 942 square feet of brick for that wall, whereas on the inner layer, we're showing 919 square feet of gypboard. Now again, that may not seem like a huge difference, but as we tally that up across an entire building project, it could actually make a very big difference on our estimate of the total cost. We can add conditional formatting to schedules to help draw our eye to items that may need a little more attention. For example, on the material item cost, if there's any of those items which are over, say, $5,000, we can highlight them so they'll stand out and we'll know to look at them more closely. How we do that is we choose the field that we want to apply the conditional format to, click the conditional format button, then set up the condition that will be tested against. For example, if we'd like to highlight any items where the materials cost is greater than or equal to, say, $5,000. We can choose a background color that'll appear in those cells of the schedule. Let's click OK, OK, and OK again, and you'll see that these specific items all meet that criteria and they're highlighted in yellow, so we can pay more attention and make sure that those costs are accurate. Having access directly to this cost information within the Revit environment gives you great power by providing immediate feedback about design alternatives to help guide and inform your design decisions. Based on the feedback in the cost schedules, you can flex your model and test new alternatives. For example, we can activate this model view choose a different type of roof construction, and immediately see the impact of that decision in the cost tables. We can also use the schedules to explore the impact of changing different materials costs. For example, let's look at the impact of using a less expensive material for our glaze system panels. We can enter the new value directly into the schedule and very quickly get feedback on the impact of this decision on our preliminary estimate of the project cost. You'll see that making that change is estimated to save approximately $200,000 in the materials cost for the project. We could also look at the impact that making changes to the size or shape of our building would have on the preliminary cost estimate. Let's switch back to that sheet view so we can look at the building as well as the cost estimate together. We'll activate our view of the building, and we'll also turn on the mass, which is being used to define this shape. And then select the conceptual mass by tabbing until we can select it. Once the conceptual mass is selected, we can edit the parameters that define the shape of this conceptual mass. For example, let's change the building depth from 200 to 180 feet and apply that change. You'll see that the conceptual mass has changed shape, so now we need to select the walls, floors, roofs, and curtain systems and update them so they adapt to the new shape. I'll drag select to get all of the walls, floors, and roofs quickly. Then filter this selection to only select those elements, choosing the walls, roofs, and floors. Say OK. And now we can say Update to Face. And all of those elements will update themselves to conform to the new shape of the conceptual mass. We'll select the curtain systems individually, but use a very similar procedure to update them also. Tabbing to select the curtain system, then saying Update to Face. Tabbing again to select the curtain system on the back, and updating that one to the new faces also. The power, again, of working with the conceptual masses is that we've made some very basic changes to the size and shape of the building. We see it in the 3D model, but we're also getting revised feedback in our preliminary cost estimates, so we can immediately gauge the impact of the size change on our preliminary estimate of the building cost.